Hi, I'm Hugh Breslin with Microchip's FPGA business unit. In this video, we're going to have a look at what is the HSS or Hart software services for PolarFire SoC. First, we'll have a look at the role of the HSS in system startup. Then we'll have a look at building the HSS and the specific configuration steps you need to take on Windows. And finally, we'll have a look at configuring a HSS. So first, what is the function of the HSS on system startup? First, the first thing to note is that the HSS code is stored in the ENVM of PolarFire SoC, and the MSS boot mode should be set to 1. In this mode, the Hart reset vectors are all set to start from the ENVM. When this happens, the bare metal startup code that's used by the HSS is going to be run, which configures the PolarFire SoC system, such as the MSS clocks and MSS I/O configuration. And then once this is complete, the HSS main code starts running. As you've seen in our demos, and if you have an Icicle kit yourself, the HSS will implement a 5-second countdown on startup. If you don't give it any input in this 5 seconds, it will then start searching a memory source for a payload. This memory source is configured at build time to be, for example, the eMMC or the SD card. It could also be a source like QSPI. If a valid payload is found, the payload gets unpacked into the DDR on the kit and then loaded into its relevant memory location. And the HSS knows this information from a header that's generated in with the payload. Once the payload's been unpacked and loaded into its memory locations, any cores associated with the payload will then be started up. So the key points to note is that the HSS application code is small enough to fit in the ENVM of a PolarFire SoC part. It'll allow the booting of images that are bigger than the onboard storage of the SoC FPGA. And then finally, it will allow the programming of those storage locations. So for example, on PolarFire SoC, we have a 128K ENVM, but we have an 8GB eMMC available off-chip. The HSS allows us to program the eMMC, and it also allows us to copy an image from the eMMC onto our DDR and use it to start up our system. And if we were to have a look at that graphically, we have our MSS that contains our cores, and when that starts up, it'll execute code that's contained in the ENVM. At this point, our E51 and the U54 application cores will all be executing the HSS. Once the 5-second timeout has been completed, the HSS will copy code from a memory source into the DDR and then load it into the relevant locations. Once this is complete, the application cores associated with that payload will then stop running the HSS and start running the application code. If you wanted to program an off-SoC FPGA storage, such as the eMMC, you can do that using the USB-D MSC service that's included with the HSS. And if you want more info on that, have a look at our video called Getting Back to Factory Defaults. Okay, now let's have a look at building a copy of the Hart software services. If you're running on Windows, you need to install an extra tool to do this. It's msys2. To download a copy, go to msys2.org/installation and you'll be taken to this page here. You can download a copy of the installer and then follow the steps listed on the page to set up msys2. Once that's done, you can launch an instance of msys264, and then you need to install 3 packages. They're Python 3, Python 3 pip, and make. To install them, type in pacman-s, and it's a capital S, followed by make, Python 3, and Python 3 -pip and hit enter. Once it asks if you want to proceed with the installation, click yes or enter yes. Now that they've finished installing, I want to use pip3 to install a Python package called kconfiglib. To do this, type in pip3 install kconfiglib and hit enter. Now that that's completed, I just need to add the path to the msys2 make directory to my system properties, or my system environment variables. To do this, open up System Properties and select Environment Variables. Under System Variables, scroll down to Path, and if I double click, I can open it up to edit the environment variable. Make sure you've added the path to your msys64 installation and the user bin folder. This is used by SoftConsole to build the HSS, and you'll get an error if you haven't added this to your system path. Now that I've done that, I can continue on to build the HSS. If you go to the PolarFire SoC GitHub organization, the HSS can be found in the repositories. If I open it up here, you can clone or download a copy of the HSS. Once you've done that, open up SoftConsole version 6.4 or greater and select File and then Import, and under the General heading select Existing Projects into Workspace and click Next. Browse to the folder where you downloaded a copy of the HSS repository and select the folder. When SoftConsole finds the Hart Software Services project, make sure it's selected and click Finish. Now that it's been imported, I can see it in the Project Explorer on the left hand side, and you have to do one step, which is to configure the actual HSS build you're going to use. For this example, I'm going to use the default eMMC configuration. If you open up the boards folder and then the iciclekit-es folder, there are two defconfig files, a defconfig and defconfig.sd card. The first defconfig is for the eMMC configuration, and the .sd card defconfig is for the SD card configuration. Copy the one that applies to you and paste it into the top level Hart Software Services project folder. Find it in the top level folder and rename the file. In this case, we just want to call it .config and then click OK. Once you've done this, make sure you've selected the Hart Software Services project and build the default build configuration. Okay, so now let's have a look at configuring a HSS build. One thing you might want to change is the XML that's used by the HSS. For example, if you change the MSS configuration with a different clock frequency and you wanted to build this XML in with your HSS. To do this, open up the Hart Software Services project. Open up the boards folder and then select your target. And in my case, it's the Icicle kit. In here, there are two SoC folders. The SoC config folder contains the generated SoC configuration header files that are produced by the XML. And the SoC FPGA design folder actually contains the source XML. When you replace this file during a build, the SoC configuration generator is run, and it replaces the contents of the SoC config folder. So to update the SoC configuration, you just need to update the XML file that's shown here. Now if you wanted to reconfigure the HSS with different functions, so for example, the default HSS build includes the USB-D MSC service, but if you wanted to include a service such as Y modem, you'd have to use kconfiglib and the menu config system to actually configure the HSS. I've MSys2 opened up here, and I've changed into the folder that contains the SoftConsole project for my HSS project. The reason I've done this is that I downloaded the Hart Software Services Master repository into my downloads folder, but I copied the project into my SoftConsole workspace. So my SoftConsole workspace is in my D drive, which is separate to where I cloned the repository. So make sure that you've changed into the correct folder. Once you've done that, in my case, I've already copied the Icicle kit defconfig into my top level project folder. So if I type in make and then in all caps board equals Icicle kit or Icicle-kit -es config, it opens up the configuration dialog for me. So there are several options you can configure. For example, in service, you can select the target address for where packages get decompressed. So this is the DDoR location that will be used to decompress an image when it's being copied from a source destination. You can also configure, for example, if you have MMC support, and the MMC mode that's used, so eMMC or SD card, and the voltages that are supplied. You could add in QSPI if you are using QSPI as a storage medium, and several other services. For example, as I mentioned, Y-modem. If you wanted to enable in service, press space to select it. And the same applies if you wanted to deselect a service. There are compression options available. You can configure the general build options. So for example, if you wanted to include OpenSPI or not. You can configure the build options and then also the debug options. When you've finished configuring the HSS, if you enter Q, it'll quit, or you can save and quit by pressing S, and this prompts you to name your file. So this file will be named .config, which will be used when I actually run a build. And if I hit Q now, I exit the menu configuration utility.